Okay, in this segment we're going to start studying data in ML that's built out of smaller pieces of data, and we're going to start with pairs. So we've seen numbers, we've seen booleans, those are our basic data values, and we've seen various ways to program with them, like conditionals or variables or functions. But we need some way to build up things that have fields, multiple parts of them. This is essential in any programming language. If you've programmed in a language like Java, you've probably programmed with arrays that contain multiple pieces, or you've programmed with classes that had multiple fields, that sort of thing. In ML, we're going to take a very sort of fundamental approach to it. We're going to start with tuples, which are a very direct way to have a fixed number of different data items, each of which can have different types. And then in later segments, we'll start programming with lists that can have any length at runtime, but all the pieces have to have the same type. These are not the only forms of compound data we'll study, but they'll be enough for the first homework assignment, and they'll get us started. So we'll start with pairs. And the way I want you to think about pairs is that they're just things with two parts. And so in terms of new language constructs, we need a way to build pairs, and we need a way to access the pieces of pairs. So here on this slide, I have the pair building expression, and I have the answers to our three questions about them. In terms of syntax, we're going to write two expressions. We're going to separate them by a comma, put them in parentheses, and that's the syntax for building a pair. What are the evaluation rules? Well, what we're going to do is evaluate E1 to some value, call it V1, E2 to a value, call it V2, and then that pair of values will be a value. So one new kind of value, something that's done evaluating, is a pair that holds itself values. We also have a new kind of type for these pairs. So if E1 has some type, say TA, and E2 has some type, say TB, then the pair expression will have TA star TB. So it just has the two parts of the pair, the types of those parts, separated by a star. So that's how we build pair expressions. Now how do we access the pieces? Well, I'll show you a different way in the future, but for now, let's use these two constructs, #1 of an expression and #2 of an expression. The evaluation rules are that we're going to evaluate that expression E to some value. It's going to be a pair, and then #1 will return the first part of that pair, and then #2 would return the second part of the pair. So if x is, say, the pair of 4 and 17, and we said #1 of x, we'd get back 4. Type checking works similarly. That E in there better have a pair type, so it better be some TA star TB, otherwise this access expression doesn't type check. And then #1 of E would have type TA, and #2 of E would have type TB. So those really are the rules, but like anything, you tend to really understand how they work by writing some programs and trying them out. So let's just write a few functions that take or return pairs. So how about I start with a swap function. Maybe it takes one argument. I'll call it PR for pair. Maybe it has type int star bool. So it takes something whose first part is an int and second part is a bool. And maybe what I want to return is a new pair where I build the first piece out of #2 of pair and the second piece out of #1 of pair. All right, so I'll show you in a second an example of how that works. In the meantime, how about I just write some other functions here? How about I write a function that takes two pairs, both of which have type int star int, and just adds up those four pieces that are in there. So what I want to return is #1 of pair 1 plus #2 of pair 1. I can grab these four pieces in any order I want. #1 of pair 2 plus #2 of pair 2. It's a perfectly reasonable function. It takes as arguments two int star ints and returns an int. So the type of this whole thing would be int star int, star int, and it returns an int. And let's put that in a comment. All right? Let's do a couple more. Oh, here's one that I really like, because this is something that's just completely natural to do and a pain to do in many programming languages. Let's take in a numerator and a denominator, x and y, so just two arguments of type int, and let's return x divided by y and the remainder of x and y. Now these operators have strange names in ML, div and mod, but I can still write this. All I'm doing here is returning a pair of two expressions, the result of x div y and the result of x mod y. And so this function is going to take in two ints, int star int, and it's going to return a pair of ints. The read eval print loop, when we actually print this out, won't write those parentheses, but it's just that simple. All right, how about one more? How about we take in a pair of integers and we sort that pair. So we're going to return a pair of int star int. Okay, and if the first part of the pair is less than the second part of the pair, then we'll just return the pair we started with because it's already sorted. Otherwise, let's swap it around and return #2 of pair, #1 of pair. All right, so that seems like a good set of example functions. Let's real quickly go over here, make sure that I actually wrote those correctly, and they load up here. Good. We see that swap has type int star bool, arrow bool star int. So how about I try that out? How about I try calling it with 7 and true, and I get true 7. If I call it with, let's say, -4 and false, I should get false and -4. Now you might be thinking, how does ML know that I'm calling it with a pair and not calling it with 2 arguments? Well, in a future lecture, I will show you that in ML that's actually exactly the same thing, but for now, we'll keep them as separate concepts. And let me try one more here. How about sort pair of 3, 4? I just get back the pair 3, 4 of type int star int. If instead I had maybe had a value that was 4, 3, and then I had said sort pair of x, it would come back 3, 4. Of course, I could have just directly asked sort pair 4, 3. I would get the same answer, of course. OK, so that's programming with pairs. Let's go back to the slides here and show you that while that's really all there is to pairs, we can in fact generalize this idea to tuples. So a pair is just a 2-tuple. In general, you can have any number of pieces. So to build a tuple with n pieces, you just have n expressions separated by commas. The type of that thing will be all the types of the expressions separated by stars. So something like int star int would be a triple where each piece was an int. And you access the pieces with #1 of e, #2 of e, #3 of e, and so forth. So you'll get a lot of experience on this because int star int is in fact a common type for a lot of the problems on the first homework assignment. I also want to emphasize that without adding anything new to our language, the rules I already showed you, you can nest tuples and other kinds of expressions as deep as you like. So I have a few examples here on the slide. We could type these into the read eval print loop or into an ML file as well. But for example, if you write 7, and then in its own pair, true, 9, well, that's going to be a pair where the first part has type int, and the second part is also a pair of type bool star int. So the overall type is int star parenthesis bool star int. Therefore, if you took that x1 and you applied the #2 operation to it, #2 of x1 is going to give back a bool star int. So if we then did #1 of that, so #1 of #2 of x1, that would give you back something of type bool, and in fact x2 would evaluate to true. Similarly, x3, which is just #2 of x1, makes perfect sense. The result, we look up x1 in our environment, we get 7, true, 9. We do #2 of that, we're going to get true, 9, and that's a perfectly reasonable value of type bool star int that we can then bind to x3. And of course, these things can nest however deep you want. So on this last line here, maybe it's hard to follow all the parentheses or whatever, but we just have a pair whose first part is a pair of ints, and whose second part is 2 pairs of ints. And sorry, it's a pair of ints. Hard to talk about, easy to program with, and you can see the type written here. So that's tuples.